If you are preparing for CSIRNET, GAT or IIT JEE exam, or you are doing the MSc or BSc, and if you have problems in the quantum mechanics questions, then see these 5 unseen questions. These questions you have not seen. And if you are doing these questions, actually there are 5 questions and 5 concepts. Okay. So by doing these 5 questions, you are clearing your 5 concepts, 5 basic concepts, 5 fundamental concepts of the quantum mechanics are clearing here. Okay. So firstly, watch these questions and try to understand what type of questions I am giving you. Okay. So, hi students, I am Priyanka Jain and you are watching the chemistry classes of Priyanka Jain. Okay. Here I am giving you 5 questions of the quantum mechanics so that you can clear your concept. Okay. If you want to see more such type of questions, then you can visit our channel and you can see the quantum mechanics whole playlist. Okay. You will find several different type of questions. And if you want a detailed course of the physical chemistry for the CSIRNET or GAT exam, then you can visit our app. At our app, we are soon starting a course for the physical chemistry in a very efficient amount. Okay, so this course will be in a very minimal amount so that you can purchase it. Okay, and you will get, beside this, you will get the PDFs, assignments in the written form, and with that you will get the mock test and their solutions. You will also get your ranks. Okay, so this course will be very much beneficial for you. Course is starting from 1st of January. This will be for the June 2025 examination. Okay, so if you want, you can visit our app. The link will be given in the description box. Okay, so see here, this is a question. First number question. A normalized state phi is constructed as a linear combination of ground state psi naught and first excited state psi 1 of some harmonic oscillator with energies 1 by 2 and 3 by 2 units respectively. If average energy of the state phi is 7 by 6, the probability of finding the psi naught in phi will be. Okay. Here you have given 1 by 2, 1 by 3, 1 by 4 and 1 by 5. Okay, so first of all, you should know that you have given that your wave function here, see, this is given to you. This is your wave function, okay? You can see here, this is your wave function phi that is given to you. And this is a linear combination of two wave functions, psi naught and psi 1. So what you have to do, you will have to make a linear combination, okay? So how you can make a linear combination? See here, you will write in this manner. Phi is equal to C naught psi naught plus C1 psi 1. Here C naught and C1 are the coefficients. You know these coefficients if you have seen my lectures. Okay. And what you have to do, firstly think, there is given that phi is normalized. Okay. Whenever you have given a wave function is normalized and it is a linear combination of two wave functions, then their coefficients square. It means C naught square plus C1 square will be equal to 1. Or what we can write? We can write C1 square will be equal to 1 minus C naught square. Okay. So you can write here C naught square E. This is for the energy term. And C1 square E. This will be E naught and this will be E1. Will be equal to, you have given, this is 7 by 6. Okay. The average energy you have given, that is 7 by 6. So you can write here. Okay. Now just see here. You will have to put the values of energy that is given to you. One is 1 by 2 for ground state. C1 you have not given. But you can write 1 minus C naught square here. And even you have given, that is 3 by 2. The energy of the first excited state you have given. Now you can open the bracket. You can write C naught square by 2 plus 3 by 2 minus C naught square by 2, and here you will have to write 3, will be equal to 7 by 6. Now what you have to do, see here, this 3 by 2 will go at this side and this will change to minus term. Okay, so overall you are getting this C naught square by 2 minus 3 C naught square by 2 is equal to 7 by 6 minus 3 by 2. Now you can do the yourself. Okay, you can do it. So firstly try to do yourself. Okay, every question firstly try to do yourself. This will give the confidence to you. Okay, so once you do, you will find out that C naught square is equal to 1 by 3. Now you know that this coefficient square is equal to probability. Okay, so you can write this is the probability. So the probability of finding psi naught in the phi is equal to 1 by 3. Now you can match in your options. See here, you have given option number B, 1 by 3. This is your answer. Okay, let's see the next question. See here, this question you have given. sp hybrid orbitals are of the form C1 2s plus C2 2pz. Here 2s and 2pz are normalized individually. Okay, the coefficients of the normalized form of above sp hybrid orbitals are. So here in this question, you have given about the 2s and 2pz orbital. One thing you have given that your orbital is sp hybridized. Okay, so you can make a wave function in this manner. Psi is equal to c1 2s plus c2 2pz, and that is normalized. Whenever you have given a wave function is normalized, that means their coefficient square is equal to 1. Okay, so from here you are getting one thing. Okay, you can put, now you have given this equation and you can put from every option the answers. Okay, firstly you will do with the option number A. On putting the value of option number A, what you are getting, 1 by root 2 square plus 1 by root 2 square is equal to 1. Now you can see that this is actually true. This will be 1 by 2 plus 1 by 2. This is equal to 1. It means we can say C1 is equal to 1 by root 2 and C2 is equal to 1 by root 2. No more values can happen here. Okay, you can see all the options. If you are putting 1 by 2 and 1 by 2, then this will not be right. Okay, you can put 1 by root 2 and 2. This will also not be right. Okay, the only options that is matching here is this option number A. So option A is right. In this way, sometimes you have to go through the options firstly, okay, and then you have to do the question. Okay, now let's see the next question. See here this question. Here you have given the correct statement about both average value of position and momentum of a 1D harmonic oscillator. You have given 1D SHO wave function is. Okay, you have to find out the average value of position and momentum. And if you have seen my video lectures, you know that this value is equal to 0. Okay, so if you know, if you have learned that, you easily can do without doing anything that this value, average value of x will be 0 and momentum will be 0. But if you don't know, if you have not seen, then you can do here. Okay, so see here the answer. What will be the answer? For 1D SHO, firstly you should have a basic knowledge of the wave functions. You should have the knowledge of the all wave functions, okay, given in your syllabus. So psi naught is equal to beta by pi 1 by 4 e to power minus beta x square by 2. Okay, now firstly you have to find out the average value of x. That will be, you are putting here limits plus infinitive to minus infinitive psi square psi star x psi dx. In this way you are doing. Okay, so you are getting plus infinitive to minus infinitive, and here you are writing beta upon pi 1 by 4 e to power minus beta x square by 2. Okay, then you are writing x, then you are writing beta by pi 1 by 4 e to power minus beta x square by 2 dx. Okay, now these terms you can see here, this term and this term. This is a constant, you can multiply them and put outside the integration term. Okay, so you are getting, you will write beta by pi, by multiplication you are getting 1 by 2 plus infinitive to minus infinitive. Okay, and you are writing here x, and see here when you are multiplying these terms you are multiplying, you are getting eta minus 2 beta x square by 2. Okay, 2 to 2 will cancel out, so you are getting here eta to power minus beta x square. Okay, so you will write down dx. Now see here, this is x to power 1, and when you have given an integration in this manner, okay, this is an odd function. This is an odd function, and you should know if you have cleared your basics of the integration. Okay, in my syllabus of the physical chemistry course, I have firstly dealt with this. Okay, I have firstly tried to clear all the integration and differentiation terms for the biological background students. So you can easily go through that. Okay, so this is if odd function, then this whole integration will be equal to 0. It means this integration is 0. This is equal to 0. Then this whole term will be equal to 0. So you are getting the average value of x is equal to 0. Okay, this you are getting. Now you can see the average value of the momentum. Similarly, you have to do plus infinitive to minus infinitive psi star px psi dx. Okay, then you are doing in the similar manner plus infinitive to minus infinitive. Here you are writing beta by pi to power 1 by 4 e to power minus beta x square by 2. Then you will write iota h cross d by dx. Okay, minus sign I am putting here. Okay, then you will write down beta by pi to power 1 by 4 e to power minus beta x square upon 2 dx. In this manner you will write. Okay, this constant term and this constant term will get multiplied and go outside, and this iota h cross is also a constant term, so it also comes outside. So you will write minus iota h cross beta by pi 1 by 2 plus infinitive to minus infinitive e to power minus beta x square by 2 d by dx of e to power minus beta x square by 2. Okay, once you are doing the d by dx of e to power minus beta x square by 2, this value will be equal to this value. See here, I am writing here d by dx of e to power minus beta x square by 2. See here, when you are doing the integration, this once you are getting e to power minus beta x square by 2 and d by dx of minus beta x square by 2 will be equal to minus 2 beta x by 2. This one. Okay, so you are getting minus beta x. So this minus beta will go outside. Okay, this you are getting. See here, I am writing here minus iota h cross beta by pi 1 by 2 here. Okay, and this minus, see here, this minus beta, this you have given, so this term will go outside, minus beta. So you are writing this minus beta term also outside. Minus to minus will cancel out. Okay, then here you are writing the integration, and x will go inside the integration because it is a variable. Okay, so you are writing here x, and then you are writing here eta to power beta x by square by 2, and again e to power minus beta x square by 2 dx. This one. So you are getting here beta, I am writing here iota h cross beta by pi to power 1 by 2 plus infinitive to minus infinitive x, and this will add. So you are getting eta to power minus beta x square dx. In this manner you are getting, because you are getting here in this manner 2 beta square by 2, and 2 to 2 will cancel out. Okay, so in the, see here, in this manner you are getting minus beta square by 2. Okay, so this answer, when you are seeing this is x to power 1, and this integration, you all know this is a odd function, and this integration will be equal to 0. So when this value is equal to 0, you are multiplying with this, you are getting all the term will be equal to 0. It means you can write that the average value of px is equal to 0. Means to say, if you are seeing your answers, see here in option number C, you have given the average value of x is equal to 0 and average value of momentum is also equal to 0 in 1D harmonic oscillator. Okay, this thing you should learn. Okay, once you learn this, you does not need to derive it. Okay, let's see the next question. See here, you have given for a particle of mass m confined in a rectangular box. You have given a rectangular box with sides 2A and A. The energy and the degeneracy of first excited state respectively are. Means you have to find out firstly the energy of the first excited state, then you have to see the degeneracy of the first excited state. It means how many states of the same energy are present here. Okay. So see here how to deal with this question. See here, you have given for 2D box of length 2A and A. This you have given. Okay, for this E is equal to h square upon 8m nx square upon lx square plus ny square upon ly square. This will be the formula. Okay, now what you have to do? You have given the lengths are of two types. Okay, so you can write nx square upon 2a whole square. Okay, and ny square upon, here you have given a square. When you are doing in this manner, what you are getting? H square upon 8m. You can take common terms. So you are getting nx square plus ny square, nx square plus 4 ny square upon 4a square. In this manner you are getting. Okay. Now see here, for first excited state, there may be two conditions. One thing may be nx is equal to 2 and ny is equal to 1. Or another condition may be nx is equal to 1 or ny is equal to 2. There may be two different probabilities. So we have to deal with both the things. Okay. So firstly we are seeing, suppose we have given if nx is equal to 2 and ny is equal to 1, then what you are getting? This is written as E21. That will be equal to h square upon 8m 2 square plus 4 into 1 upon 4a square. Okay, so this will be equal to h square upon 8m 2 upon a square. This is the value of this state. Okay, E21. This you are getting in this manner. Now you can see the second case. If nx is equal to 1, we should try for both the probabilities. Okay, because any of the condition may have the lower energy, so that will be the first excited state. Okay, so when you are seeing in this manner, what you are getting? Now you have to put for nx1, it means 1 square here plus 4 into 2 square upon 4a square. So you are getting, this will be equal to actually h square upon 8m 17 upon 4a square. If you are calculating this, this will be equal to h square upon 8m 4.25 upon a square. Okay, now you have given two different conditions. One is this one, two states. Two states you have given. Okay, and you have to find out the first excited state. It means the state that is after ground state. It means that state that will have the lower energy. So you can see that this state is having the lower energy. So this will be the first excited state. Okay, this is first excited state and this will be your second excited state. Okay, so means to say both the states are not having the same energy. It means the state of the above energy. It means first excited state is only 1. There is only one value for the first excited state, that is E21. So the degeneracy, if you want to find out, the degeneracy of this state will be equal to 1 because there is only one state, that is E21. Okay. So in this way you have to do this question. Now if you want to match in options, see here. In option number 1, you have given, see here, h square upon 8m, 2 upon a square and 1. This is your answer. Let's see the next question. See here, one question I have taken from the commutator because from the commutators also the questions are asked. Okay, so see here, this is a question, the value of commutator x, xpx is. This question is quite easy. If you have know about the tricks that I have told you, then you can do these questions very easily. Okay. So if you want to see in the short manner, then you can see in our video lectures of YouTube. And if you want a detailed course of this, then you can go to our app. Okay. Firstly, see, you have given this thing. This thing you have given. Okay. And you have to find out this one. For this, you have nothing to do. If you know my tricks, I have told you that one thing I have told to learn you, that the commutator of x px is equal to iota h cross. This you should know. Okay, this is very much important. So once you know what you can do, you can put its value here. So you are getting the commutator of x and iota h cross. Now you have to find out. And one thing you should know, that the commutator of anything with the constant value is always 0. Okay, this I have told you. So this will be equal to 0. Okay, means to say this commutator that you have asked, you can find out this in 3 lines only. Means to say just in 2 lines you can find out this thing. So without any time wastage, you can find out your answer is 0. Okay, so in this way you have to do the questions of quantum mechanics. There is nothing to worry in the quantum mechanics. You can do such questions very easily, and if you want the detailed course, then please ask me. Please see the description box, the links are given, so you can do these questions quite easily. Okay, meet you in the next video. Try to do more and more questions and prepare well for your exam, because exam is very much near to you. Okay, so do your best in your exams. Meet you in the next video. Thank you.